yesterday we reviewed geometry with your right triangle trig. Today we're going to look at angles and in standard form, which means they're going on the coordinate plane. Okay, you're used to angles being inside of figures that are just randomly all over the place, or maybe you draw some random parallel lines, you got angles in there or whatever, but we're putting them on the coordinate plane. Okay, and they can be anywhere on the coordinate plane, but we're specifically going to talk first about them being in what's called standard form. So if you have an angle on the coordinate plane in standard form, that happens when the vertex is at the origin, so right here at the origin, and one ray lies on the positive x-axis. So this is where we start that angle, okay? So we start there on the positive x-axis. The ray on the x-axis is called the initial side because this is where we, oh, well, let me spell it right. Initial side, this is where you start. Okay, since that's where we're starting the angle, it's also where we start measuring the angle. So this would be 0 degrees right here. Then the other ray, this one over here, is where we stop the angle. So it is called the terminal side. All right. When you rotate counterclockwise, like so, right here, that results in positive angle measures. If I started here and went this direction to end here, and I'm going clockwise, that results in negative angle measures. So, if you have ever been told that you can't have a negative angle, that was a straight up lie. You might not have been able to have a negative angle in whatever you were doing. You're not going to have a negative angle in some random triangle that you have or something like that, but you can totally have negative angles on the coordinate plane. When we talk about things on the coordinate plane, we also talk about the quadrants. Okay, so let's talk about where our quadrants are. This is quadrant 1. This is quadrant 2, 3, and 4. And when you first learned that, it probably didn't make a whole lot of sense to you why it was in that order when everything else we do in life is from left to right. But this is kind of the why. Because we start at 0 here and rotate around, this would be 90, 180, 270, 360. That's why it goes 1, 2, 3, 4. Okay? And you got to know which quadrant is which. I'm not reteaching you. Figure it out if you don't know it, because my goodness, that is old business, and you got to know it. Okay? We good? All right, any questions? Awesome. All right, so the most common unit of measurement to measure angles is the degree, the only one you are most likely very familiar with. Okay, there's a little degree sign. Start here at 0, go all the way around to 360 degrees. So a degree, meaning 1, is equivalent to 1/360th of a full rotation. So knowing all that stuff, we are going to sketch our angles on these little coordinate planes, but we're going to sketch them as accurately as possible. We're not going to get out little protractors or anything, but we can still be pretty accurate. If it's going to be in standard form and I want this to be 135 degrees, I know that I start here, that's at 0, right? If I go to here, that's 90, all the way to here is 180. So it's somewhere in the second quadrant. So if I subtract 90 from this, what do I get? Oops. What's 135 minus 90? 45. Okay, so that means I go 90 plus another 45, which would be halfway. So I can definitely get it looking semi-accurate, like so. But I can't just stop there. You have to show the little curvy arrow that shows the rotation. My angle starts here and ends here, and that's 135 degrees. Okay, we good? All right. So 495. Maybe that seems ridiculous because you didn't think angles could be that big. They can be that big. They could be negative 495. They could be 5,872 degrees, whatever. Would make sense in a little triangle again, but you know. So we're going to start here. I know that if I go all the way around to here, that's 360. That's clearly more than 360. So if I subtract 360 from 495, what does that give me? 135. Again. So I know where that one ends. It ends right here. So I start and stop in the same spot, but it's not the same angle and it's not the same path if you were going to like walk the path. I would start here, I'd have to go all the way around and then keep going to end up there, and that is 495 degrees. That's why those little arrows are important, because you got to, it shows your rotation in which direction you're going. What questions you got? We good so far? All right, so then I have a negative 140. I still start here, but this time, since it's negative, I'm going to go clockwise. So if I start here, this would be 90, that would be 180, but 140 is in here somewhere. So after I hit 90, how much farther do I go? 50, and that's just a little past halfway, so about right there. And then I show this arrow to show that it's negative, and that's negative 140 degrees. What questions do you have? All right, so then let's talk about another way to measure angles, and that is in radians. Radians are introduced to you in geometry as well. You most likely were just shown what a radian was when you did arc length. It may be converted back and forth, and maybe not that much more than that. So I'm going to show you a quick video here, and then we'll talk about it.
We start with a circle of radius r. We take that radius distance and wrap it around the circle. The angle formed by that radius distance is 1 radian.
Okay, so repeat what he just said. Whatever this radius is, in this case it was just, they just said it's a radius of 1. So I wrap this around right here, so that's the same length, it's just bended because it goes around the circle. 1 radius equals 1 radian. If this was 5 centimeters, the length of this arc right here would be 5 centimeters. Does that make sense? So all 3 of these pieces would be the same length, all right?
Since the circumference of a circle is 2 pi r, there should be 2 pi radiuses in a circle.
Okay, so here, 1 radian, 2 radian, 3, a little bit more than 3 radians, right? And a little bit more than 3 is pi, 3.14. So to get from 0 to 180, that is pi radians. Make sense? Because it's a little bit more than 3 radians. Okay.
So halfway around the circle, we would expect 1 pi radian. And around the entire circle, we would expect 2 pi radians.
Okay, so makes sense for radians? So 360 degrees is the same as 2 pi radians, regardless of what the length of the radius is, because like I said, if we had, go back here where so if my radius is 5 centimeters, then this is 5 centimeters, but it is 1 radian, and then that would still be a little bit more than 3 radians, regardless of whether it was 5 centimeters, 10 centimeters, 1 centimeter, whatever, the amount of radians. So we're measuring the angles in terms of arc length instead of in terms of a degree, right? It's just a different way to do it. We good? And you will learn real quickly, you're not going to believe me at first, I know, because nobody ever does, but you're going to like radians way better than degrees, because they're actually easier once you get your mind wrapped around it and make a whole lot more sense than having all those bazillions of numbers in your brain. All right, so a radian is a unit of angle measure based on arc length, like we just said. So 1 radian is defined as the measure of the angle formed when the radius is equivalent to the length of the intercepted arc. That's what a radian is, okay? And then it says, recall, because we should know this, that the circumference of a circle is 2 pi r. Therefore, 360 degrees is 2 pi radians, and 180 degrees is pi radians. Honestly, if you got that down, you can figure everything else out, okay? So if we want to convert from degrees to radians or radians to degrees, if I want radians but I have degrees, I'm going to use the little proportion. I could use 360 and 2 pi, but it reduces to the 180 and pi, which makes it easier. So if I have degrees, I'm going to multiply by pi over 180. If I have radians, I'm going to multiply by 180 over pi. This is how you make sure you don't get it backwards. If I have degrees, I need to multiply the pi into it. If I have radians, I need to divide the pi out of it. It's that easy, okay? So once again, here's 1 radian, or the radius is the same length around here and around there. That's what a radian is. So let's convert. It says to convert and to state the quadrants. All right, so let's talk about quadrants real quick. So I know that this is 0 degrees, and then 360 if I go all the way around. Then this would be 180. So this is 90. What would this be? 270. Okay. Oh, and my coordinate plane is very crooked, but let me fix that. That's what happens when I write sideways. Oh, that's not any better, but whatever. It's probably worse. You get the idea. Okay, so we're going to convert. So first of all, 60 degrees is in which quadrant? It's in quadrant 1. It's right here, right? It's in quadrant 1 because it's between 0 and 90. So first quadrant, we can answer that first. So then I'm going to convert. I'm going to multiply. Since I want radians, I'm going to multiply it by pi over 180. These zeros can reduce down. That leaves me with 6 pi over 18, which would become what? Pi over 3. And it would always be pi over 3, never like 1/3 pi. It's always all in one. Everybody good with that? All right. So then 160. What quadrant is 160 in? So I'm here. It would be in the second one because it's less than 180. Right? That's okay. It's less than 180. All right. So then I'm going to multiply by pi over 180. The zeros reduce out, leaves me with 16 pi over 18, which would become what? (16 pi over 18) can reduce to 8 pi over 9. Yes, ma'am. Why am I multiplying, but it's not pi radians? Oh, just because I also didn't put the degree sign. Oh, and okay, I see. Why am I not using the units? Is that what you're asking me?
I guess
because it is pi radians. I just didn't, just like with 180, even if we had the degree sign there, I wouldn't put the degree sign down here, like when you do the work.
Oh, that's just the.
That's just, yeah, that's just the units. Yeah, radians are just the units. All right, so the negative 330, what quadrant would that be in? 1. Because I start here, right? I go this way because it's negative, almost all the way to 360, but it's 30 less, so I'm in quadrant 1. Okay, good. And then I'm going to multiply by pi over 180. The zeros reduce down, so that leaves me with negative 33 pi over 18. And what does that become? Yep, negative 11 pi over 6. Okay. Everybody good with that? What questions you got? Okay, so one thing that you need to wrap your mind around and get comfortable with is counting fractionally around the circle. Okay, and that's way easier than it sounds. And I know I didn't draw an actual circle here, but that becomes a little much. Just pretend like there's a circle. We're going to go around in a circle. Let's talk about the radians. I know that if I start here, I have 0 radians. All the way around is 2 pi radians. We agree with that? So if this is 2 pi, we know that 180 is how many? 1 pi, so it's just pi, right? So if 180 is pi, what do you think 90 is? 1/2 pi, which is pi halves or pi over 2, okay? And that's fine. All right, so now here's how you think fractionally and how this makes it that much, it's really not that bad. If this is pi halves, every 90 is pi halves, so this is 1 pi half, right? This is 2 pi halves, but 2 pi halves is pi, right? So then what would this be? We've got 1 pi halves, 2 pi halves, 3 pi halves. Then this is 4 pi halves, but 4 pi halves is 2 pi. If I keep going, this is 5 pi halves, 6 pi halves, 7 pi halves. You see what I'm talking about when I say count fractionally? And same way we did 1 pi, 2 pi, right? Okay, so when we look at this 18, right? If I want to think about where 5 pi over 18 would be, we could convert and then think about the quadrant, but I want you to start understanding how you count fractionally, even if you have no clue what that measurement is yet. If this is 1 pi, this is the same thing as 18 pi over 18. Would you agree with that? 18 pi over 18 is 1. So pi halves would be 9 pi over 18, right? So wouldn't 5 pi over 18 have to be in the first quadrant somewhere? Okay, you see how you reason through that even if you don't know what the measurement is? 18 pi over 18, tell it something else. 18 pi over 18 reduces down to pi, right? You take whatever the fraction is. If this was a million, this would be 1,000,000 pi over 1,000,000. So 18 pi over 18 is 1 pi. Half of 18 is 9, so 9 pi over 18 would be here. I'm looking for 5 pi over 18. It has to be between 0 and 9. Make sense? Okay, so I know it's in quadrant 1. Then let's go convert. So we're going to multiply. This time I need to divide the pi out of it, so I'm multiplying it by 180 over pi. Excuse me. And then 18 goes into 18 once, into 180 10 times. The pi's cancel out, so I get 50 degrees, which I can confirm is in the first quadrant. Okay. We good so far? All right. So let's talk about negative 11 pi ninths. If I start here, and I got to go negative, right? That's pi ninths. We're going to think in terms of ninths. So to go to pi, that would be 9 pi ninths, right? And then I have to go 2 more. Would 2 more get me to the halfway point? No, I'd have to go 4.5 more, right? So negative 9 pi ninths with 2 more lands me in the second quadrant. Okay, so I'm in quadrant 2. So now I'm going to multiply by 180 over pi. The pi's cancel out. 9 goes into 9 once, into 180 20 times. It's 11 times 20. Oh, come on, 220. Are we good? All right, so now I have 7 pi thirds. I know this is 0. Pi would be 3 pi thirds, right? If I go to 2 pi, what's that in thirds? 6 pi thirds, right? But I got to go 7 pi thirds, so I end up in the quadrant 1. So I'm going to multiply by 180 over pi. The pi's cancel out. 3 goes into 3 once, into 180 60 times, so I get 420 degrees. What questions do you have? We good? Okay. The more fractional thinking you can do around the circle, the easier everything becomes, I promise. All right, let's look at coterminal angles. Okay, so first of all, this should say, find an angle theta coterminal to the given angle where theta is between 0 and 360 and theta is between 0 and this should say 2 pi right there, so fix that. So a coterminal angle. Terminal means where you end, co means with or together, so we're going to end at the same spot but get there differently. If we were running around on a track here and we had to get here, I'd make you run this way and I would run this way because I don't like to run. But we would both end up in the same spot, right? You could even start here with me and lap me a few times and end up in the same spot. Your angle measure is going to be different, but we end in the same place. Does that make sense? That's what coterminal means. You end in the exact same spot, but the value is different. all right? So to get here, whether I have to go, I went around a bunch more times or I went around the other way or whatever, to get here different ways, it would be adding or subtracting 360 every time. So all you do to find coterminal or to check it is add or subtract 360 or add or subtract 2 pi radians. And there's an infinite amount of coterminal angles. That's why we were given specifics. This is where we want our angle to be, right? So I could take that 544 on number 10 and I could add 360 to it and I could get a coterminal angle. It would be a right answer, except that if I add 360 to that, my answer wouldn't be between 0 and 360, which is what it's telling me to do. So I know here then, instead of adding, I have to subtract. And if I subtract 360 from 544, I get that theta is equal to what? $184. And 184 degrees is between 0 and 360. If not, then I might have to subtract again, but that's how easy that is. Okay. So finding them is super easy, but you got to know what they mean in order to do that. Okay, so negative 170. I can't subtract 360 here, or my answer won't be between 0 and 360. So instead, I'm going to add 360. And when I do that, I get theta equals what? You're basically subtracting, so 360 minus 100 would be 260, and then you subtract 70 from that, and you're going to get 190. Okay. We good? All right. So numbers 12 and 13 are in radians. So I'm going to add or subtract 2 pi, but I need to get them in terms of what I'm looking at. So I'm talking in terms of halves. So if I'm going to talk about 2 pi in terms of halves, how many halves is that? What do you turn 2 pi into something over 2? 4 pi over 2. So 2 pi is 4 pi halves, right? Makes sense? Okay, so is 11 pi halves more or less than 2 pi? It's more. So I'm going to have to subtract 2 pi or subtract 4 pi halves. That's going to leave me with 7 pi halves. Does 7 pi halves fall between 0 and 2 pi? No, it doesn't. So that means I have to subtract again. I'm going to subtract 4 pi halves again. And that means that theta is equal to 3 pi halves, which is in that range. So this 11 pi halves, 7 pi halves, and 3 pi halves, all three of those land you in the same spot. They are coterminal angles, but we had that stipulation of having to be a certain measure. Okay, we good? All right, so then I have a negative 5 pi halves. It's negative, so clearly I have to add. So I'm going to add 2 pi, which is 4 pi halves. That leaves me with negative pi halves. It's still negative, so I got to add again. So that means theta is 3 pi halves. I got the exact same answer. Because not only were these three angles here and this one coterminal, but this one and this one is as well. They all land, all those angle measures land you in the same spot. It's just a different way to get there. Okay? What questions do you have? We good? All right. Then we're not going to do this part because we don't need to do that. All right, so let's talk about reference angles. Okay, because we need to know what the definition of a reference angle is as well. For an angle theta in standard form, so your angle has to be in standard form to have a reference angle. The reference angle is the positive acute angle, this should say formed by the terminal side and the x-axis. It's the shortest way back to the x-axis, and it doesn't matter which direction you go to get to the x-axis, it's still going to be positive because it's not in standard form. So if this is my angle right here, okay, so this is my theta, which is in here, then to get from the terminal side to the x-axis is right here. That makes this angle, whatever it is, my reference angle, okay? So it's very simple to figure out, but you got to be able to draw it and get there first. So it says sketch each angle, then find its reference angle. All right, so we're going to start with this 150. So this is my 0. I have to start there. I would go 90 and then have to go another 60. So 60 is like 2/3 of the way through. So it would look about right here. So this right here is 150 degrees. Then, got to get back to the x-axis from my terminal side. This is the shortest way to go. What would the measure of that angle be? 30, because I got 30 more to go to get to the 180. So my reference angle is 30. Make sense? Okay. So then I have this 315. I can think about it a couple of ways. I can count going this way, or I could think I'm going almost all the way, but I don't go all the way to 360. How far am I from 360? 45. So that's halfway between that 90. So I would end up right here. This is my 315. And because we just thought about it that way, I already know what my reference angle is. It has to be 45 degrees. We good? You always go to the x-axis, never to the y-axis. All right, negative 240. So I'm going to start here. I'll go this way, so this will be negative 180 and then negative 270. So I'm not hitting 270, I got to stop 30 before it, so it'll be right about here. That would be my negative 240. So then what would my reference angle here be? What would this measure have to be? 60, because I'm 30 away from that, so there's 60 left. Or you can think, if I go from here to here, that's 180, and then I go another 60. Either way, but it is 60 degrees. What questions do you have? Anything? Always the shortest way back to the x-axis. Even if you have to, even if I was down here and I had to go this way, it doesn't mean that it's negative because the reference angles aren't in standard position. And one thing that doesn't come up on here, but might show up in Delta Math, and I didn't think to say this last period. If you have an angle, let's say that we're going to draw a 60-degree angle, right? Your reference angle for a 60-degree angle is 60 degrees. Like if it is an acute angle, it's its own reference angle. Make sense? Okay, so that I think that might show up in Delta Math, and I didn't think to say that last period. All right, so let's look at these radian ones, and we're going to try and do these without actually converting. Okay, we're just going to think fractionally around the circle so that you can get used to doing that. We have 5 pi thirds. So remember this. If I have 5 pi thirds, I know that this is 3 pi thirds, right? Pi would be 3 pi thirds. All the way around would be 6 pi thirds, yes? But I'm not going 6 pi thirds, I'm only going 5 pi thirds, so I got to back up some. You with me on that? You see how to think about that? All right, so, but then let's think about what pi thirds, just pi thirds would even be. If 180 is pi, what's a third of 180? 60. So pi thirds is 60 degrees, right? So I go to get here, I go 3 of them. This is 6 of them, so I got to back up 1. That puts me right about here. This is 5 pi thirds. That means I have to, my reference angle right here is going to be just pi thirds. Everybody okay with that? Even if you weren't sure where to put that mark, you know you had to back up 1 because you knew we would know it was 6 pi sixths, right? Or 6 pi thirds, I'm sorry. All right, so then we have a pi sixths. So if this is my 0, pi would be 6 pi sixths, right? Go all the way around to 2 pi, that is 12 pi sixths. So I got to go 1 more to get to my 13, right? So I'm up here. So if pi thirds, well, what's a sixth of 180? 30. So pi sixths is 30. So that would help me get kind of where I need my angle to be right here. So I start here, go all the way around to here. That is 13 pi sixths. That means my reference angle Since I went 12 of them and I had to go one more, my reference angle is pi 6. Right? We good with that? Okay. So not negative 5 pi fourths, just pi fourths in general, just pi fourths by itself. If this is 0, well, here, this is 0. Oh, 0. And then this is pi halves, so pi fourths is halfway in between, right? Make sense? All right. So I'm here, and I'm going to go negative 5 pi fourths. So here, this is negative 4 pi fourths, because that's pi, right? And then I have to go one more, so that's halfway. I'm right here. So this is negative 5 pi fourths. So my reference angle is what? What would the reference angle be? It's 1 pi fourths, right? So just pi fourths. Okay. What questions do you have? Now, I know the radians, using them this way anyway, they may not be brand new to you, probably learned something about them, but that it's new and it's weird to think around it, but that'll get easier and easier, I promise. And I want you to notice on these graphs that we just did, if you compare the angles to their reference angles with the degrees, I mean, yeah, we did some subtraction, but they don't have a great, easy looking relationship. Look at these. 5 pi thirds, 13 pi 6, pi 6. Negative 5 pi fourths, pi fourths. If I said 27 pi sixths, the reference angle is pi sixths. 15 pi thirds, it's pi thirds. I mean, that's just the way it works. Okay, so it makes it way easier. There's so many patterns with radians. Every day I'm going to kind of show you a new little pattern that happens and help you just kind of wrap your brain around it. So you've got to practice. If you don't practice with this stuff, it's going to be a big time problem for you. All right. Okay, so one last part of the definitions here are quadrantal angles. So if I ask you what quadrant does it fall in, but it doesn't fall on in a quadrant, it falls on an axis, then if I'm at 0 or 2 pi or 360, whatever, that's not in a quadrant, right? So that makes that a quadrantal angle. So your answer, instead of saying quadrant 1, quadrant 2, quadrant 3, would be that it is quadrantal. And then you have to say where it is. It's on the positive x-axis. Okay. So when the terminal side of an angle that is it has to be in standard position lies on the x or y-axis, it's called a quadrantal angle. So here, if I'm at pi halves or 90 or any of the coterminal angles that get me there, no matter how I land there, I'm not in a quadrant, I'm on the axis, I would say it is quadrantal. And this time it's on the positive y-axis. If I'm at 180 or pi or 3 pi or whatever gets me there, then I would say it is quadrantal on the negative x-axis. And then you could probably figure this one out. This one would be quadrantal on the negative y-axis. Okay. What questions do you have? We good? Awesome.